Hi, I'm Zach from Temple University, and today I'm going to show you how to use the digital EE board. If you look at the EE board, you can see on one side it has a USB port, an on-off switch, and a DC power supply input. On the other side, you can see it has a scope, some analog instruments, and power. The scope is a 4-channel oscilloscope, which can measure any arbitrary AC waveform on the breadboard. On the analog section, we have 2 channels of reference voltages, which go from 0 to 9 volts. We have a 2-channel arbitrary waveform generator, and we have a 4-channel voltmeter. For power, we have VP+, which is a positive power supply, VP-, which is a negative power supply, and VCC, which is a set power supply at 5 or 9 volts. The other side includes all the digital components, which we will not be using for circuits 2. The main component of the EE board is the breadboard in the middle. It works that all 5 of these are shored together, all of these rows. So this row, the second row, A, B, C, D, E, are all electrically connected, but they're not connected between rows. So row 1 and row 2 are not connected. There's a little break in the middle, which just means that row 1 and this row 1 on the other side of the break are not electrically connected. Similarly, on the ends, we have 2 long columns, which are electrically connected just within the column itself. So everything next to the plus is connected together, everything next to the minus are connected together, but they're not both connected together. We're going to make a simple RC circuit and demonstrate how to use the EE board. So we're going to create an RC circuit with an input waveform of a square pulse at 50 Hertz. So we'll connect our red wire to the waveform generator, channel 1, and then we'll connect our resistor from the waveform generator channel 1 to a place which we will connect a capacitor to. So we'll connect our capacitor to the resistor, and then finally we'll connect the capacitor back to ground. Ground can be found on any one of these, which is denoted by the long bar and then the little arrow. So both these 2 pins right here are ground, these 2 are also ground, and these 2, and so on. So we'll connect it to ground, and next we have to see what our scope measurements will be. So we'll take one scope measurement at the waveform generator input itself. So we'll connect it here and then bring it to the scope on channel 4. Next, we want to see the voltage across the capacitor. So we'll take this and put it to the first terminal of the capacitor, and then we'll connect it to channel 3 on the oscilloscope. So the oscilloscope measures the voltage from the input node to ground. So if we put, as we have on channel 4 here, it'll measure from the waveform input to ground. On channel 3, it'll measure the capacitor voltage to ground. Next, we've got to connect the EE board to our computer. So we have a USB cable, which we'll plug into our computer, and then plug in to the EE board. Next, we've got a DC power supply input, which we'll connect, and then we'll go to the computer and open up our waveforms software. Waveforms will look for the device and configure the device to make sure everything's alright. And now we can see the intro panel. The right hand side has all the digital components, and the left hand side has all the analog components. So since we're using the waveform generator, let's click on WaveGen. So you can see the WaveGen has various waveforms on the left that we can choose, and we can set its parameters. So we can set its frequency, its amplitude, its offset, symmetry, and phase angle. For this experiment, we're going to use a 50 Hertz square pulse at 1 volt. So it's already set to that right now. On the right, there's a picture of what the waveform will look like. Let's go to sine wave, and you can see just a traditional sine wave, but we're going to use a square pulse for now. Let's put that off to the side. The second thing that we need to look at is our scope. So we'll click on scope here, and this is so we can measure our voltage across the capacitor and the input voltage. So right now, although nothing's running, it saved our last oscilloscope reading, but let's run the wave generator now by clicking run, and then run the oscilloscope. Nothing happens because we didn't turn the switch on the E power supply board. So I'll turn that on real quick. And you can see it's not seeing anything. Well, that's because we didn't set up the right channels. So we're looking at channel 1 and channel 2 on the right, but our circuit is connected to channel 2 or channel 3 and channel 4. So click channel 3 and click channel 4, and it looks sort of like a mess. And that's because we haven't set our offset and our range correctly. So we'll go into our range and we'll set it to 1 volt and set it to 1 volt for both of them. And then let's change the offset. So let's move this one 5 volts up. Oh, that was too high. Let's move it 2 volts up. So you can see now channel 4 is indicated in green and channel 3 in pink. So channel 4 shows our input voltage, which is what we expected, just a regular square pulse train. And channel 3 shows the voltage across the capacitor, which is just a standard charge and discharge. Let's try and set up the time scale so we can get a better picture of what's going on. So we'll set it to 20 milliseconds. That's pretty good. You can see as the pulse goes high from low, the capacitor begins charging at a fairly quick rate. Let's push this down a little bit. Yeah, as it goes from low to high, the capacitor starts charging. And it charges very fast, but you can tell, let's hit stop so we can look at it. You can tell it's not instantaneous. And then as the square pulse goes down, the capacitor begins to discharge. Okay, so here we're going to show you how to gather and acquire data using the Digilent Board E oscilloscope. One of the nice features is measure in the top. So if you don't have this pane off to the right, you have to click on measure, and that'll allow it to pop up. If you already have the pane, you can hit add, and then it'll add measurements. So let's say we want to add a measurement for channel 3. We'll click on channel 3. Let's go to vertical, and let's see the amplitude of channel 3. You click on amplitude and then click add selected measurement. And then you can see on the right it'll say channel 3, amplitude, value 990 millivolts. So that's an easy way to add a measurement. Another way you can save your data is by clicking on export. So on the export tab we can save it as various different things. So we can save our channel 3 amplitude, 990 millivolts. We can save this as a comma separated value, which is a .csv file. You can open a .csv file in MATLAB or Excel. We'll save it and replace. And there we go. We have a .csv file. Finally, you can also save this as an image. So you can hit copy as image on the edit tab, and then it's in your clipboard. Those are some easy ways to get data. Another way is you can see by holding left click, you can see, for example, the voltage at each channel at that specific time instance. Those are all the ways to measure and acquire data in the E board.